In this video, we will be going over topology and retopology. So first, let's go over what is topology. Topology, often referred to as topo, T-O-P-O, can be thought of as the layout of a model. So the topology is a roadmap of how the vertices and edges are placed to create the surface of the 3D mesh. So just think of that as how are the polygons arranged in your 3D object. So how is topology created or changed? The topology, or your model, is created as you cut into and add to your 3D object. So let's say you start from a cube and you start cutting it up. That is how you're changing the topology. So every modeling change you make to your mesh that adds a vert, takes away a vert, changes triangulation, adds new faces, etc., will all change the topology or the geometric makeup of your mesh. So examples that are topology changes: beveling an edge, extruding a face, cutting a four-sided face or a quad into a triangle, so triangulating a quad, merging vertices together, removing edges, splitting a model into pieces, just pretty much anything that adds to or removes from your mesh. So examples that are not topology changes would be moving a face, edge, or vertice, rotating a face, edge, or vertice, scaling a face, edge, or vertice, twisting or bending your model, UV unwrapping or texturing your model, or rigging and animating your model. So those, you're doing things to your model, but you're not actually changing the wireframe or changing the edge makeup of your model. So ideally when modeling, you want to have good topology. So what is the purpose of good topology? Good topology can reduce or optimize the number of polygons in a mesh. You could also just be streamlining your edge flow, making the mesh easier to work with. Having good topology will make animations or deformations more accurate or more predictable. Like if you're animating a character, for example, you would better be able to predict how his arm is going to bend if you have good topology versus bad topology. Having good topology would result in less artifacts or unwanted pinching or overlapping of geometry if it were to deform. Good topology or good topo generally makes the subsequent steps of your pipeline easier. So, for example, your UV unwraps, your rigging, your skinning, etc., those could all be a little bit easier if you had good topology versus bad topology. So now we want to define good and bad topology and then try to give some examples of those. So on the right, we have our good topology. On the left, we have the example of our bad topology. And just comparing these, you can see the one on the right has evenly spaced four-sided polygons or quads. The one on the left, there's kind of a mix of quads and triangles. You can see the lines aren't very evenly spaced. It just kind of looks like an unorganized mess. If we were to take the wireframes off, though, realistically the two models would look the same. It would just be much easier to work on the model on the right. With all of the nice edge loops, you could kind of double-click an edge loop and it would kind of wrap all the way around. If you were to double-click an edge on the model on the left, it would probably go 3, 4, 5 edges and then just kind of stop because it hit a triangle somewhere. So before we get any further into the differences between good and bad topology, I just wanted to make a quick note. So know that there's not a 100% perfect topology for every circumstance. There are good practices to follow and bad practices to avoid, but there's always an exception to these rules. It just depends on what you're working on. As it pertains to anatomy, there will most likely never be a perfect topology for a face or a hand, for example. Everyone has slightly different proportions or quirks about them, and that's what kind of makes us unique. A lot of these best practices are based off of averages and inherently will never be correct in all cases. So that being said, what is good topology? Good topology will usually consist mostly of four-sided polygons or quads. That's not to say that tris can't be used. Tris are definitely used all the time in many different circumstances. Using mostly, if not all, quads results in the creation of a grid-like surface. These surfaces can sometimes be easier to work with or easier to select elements because, again, if it's a grid, it's made up of a combination of rows and columns to some extent, so it can just be easier to select what you need. Having a mesh that's all four-sided polygons can also come in handy if the model needs to be subdivided. So think subdivision modeling or a sculpting program such as ZBrush where it subdivides the mesh. These quads should be arranged in loops to best aid in mesh deformations. So something like a statue, for example, that's never going to move, that can be all triangles and it doesn't really matter. It never needs to deform. But something like a character that's actively deforming, its mouth is moving, its arms are bending, you need to have geometry that kind of best aids in the deformations that need to happen on a per body part basis. The topology based off of each of these body parts, they have their own set of best practices, and we'll cover that and go into it in more detail later. So here's another example of good topology. And down here at the bottom you can see the artist Nazar Najenko. So with this model we can see that it's made up of primarily, if not all, quads. You can see that this is definitely making that grid-like surface, and it's also making a series of loops. It's not just a straight grid. So if we look around the eyes, there's going to be a series of loops. If we look around the mouth, there's going to be loops. Looking around the ear on the side here, you can see how it kind of loops around the ear. And all of these loops serve a purpose. They kind of help with the muscle deformations that would be happening in the face. So the other thing that you can notice is the polygons are evenly sized in space. So if we look at the head up here, there's going to be our largest polygons. And then you can see as we get closer to the face, everything's extremely organized, but the polygons in size get a little bit more smaller or compressed. Also, if we look in the nose area, they're going to be probably at the smallest around the nose, nostril area, and then around the eyes. And that's going to be, we have finer amounts of detail here, and there's going to be more deformation possibly here. So having these smaller polygons is kind of needed in these higher detail areas, as opposed to the back of the head where it's just more of a curved surface. We don't need those really, really small polygons. So here's an animated example of good topology versus bad topology. So we have our good topology on the left and our bad topology on the right. So notice how the bad example has a series of triangles at the corner of the mouth, and these are making it to where the mouth can't fully open. It's creating a pinch point. So if we look right here, there's a series of like 3 or 4 triangles, so when he opens his mouth, there's a lot of stretching happening right here. Whereas in this model, we have a better series of loops that go around the mouth that's letting it open in a better manner. Now that we know what topology is and we have a pretty good idea of what good topology is, we need to ask, what is retopology? So if we break down the word into its parts, re meaning Latin for again, and topology kind of referring to your initially created model, we'll know that retopology, often referred to as retopo, is simply the act of recreating your model again. So you're kind of modeling it a second time. So now we have to ask, why would we retopologize? The act of redoing something makes you ask, why didn't you just do it right the first time? When working organically, you might not know exactly what you want as you're making it. You may be trying out forms or shapes and just trying to see what works. Sometimes your first attempt at modeling something can be thought of as a rough draft. Retopologizing this rough draft or remodeling this rough draft can be a really powerful tool that makes continued work go a lot more smoothly. So some broad examples of why to retopologize: you could reduce the polygon count, you could streamline edge flow, making the mesh easier to work on, you could optimize the mesh to allow for better deformations or animations. You probably recognize these examples from our already answered question of what is the purpose of creating good topology? So the next question we want to ask is, how do retopology tools work? This is going to be kind of a broad answer because we're not going into the specifics of a tool set. So most retopology tools will have your rough draft model in the scene. This draft version of the model may be an extremely high poly model from a sculpting program such as ZBrush, or it might just be a messy lower poly 3D model from a traditional polygon modeling program like Maya or Modo, for example. These rough drafts you can think of as the reference mesh. It will be your goal in most cases to create a new mesh of this object with better topology or less topology. You can view this process similarly to using tracing paper. The reference mesh is the hard copy underneath, and the retopologized mesh is the tracing paper on top. So here are some more specific examples of why retopology is used. So you could be creating a new mesh ideally made mostly out of quads to import into a sculpting program like ZBrush. Quads being able to subdivide better than n-gons or triangles, there wouldn't be as many pinch points. You could be creating a final low poly of a model for a game or movie from an existing high poly sculpt, with or without the intention of baking from the high poly. You could be recreating a mesh that was quickly thrown together as a proof of concept and now you want to make a polished version of it. Or you could be creating a usable model from 3D scan data. And lastly, we'll just cover what software programs are used for retopology. So just going down the list, we have 3D Coat, 3ds Max, Blender, Maya, Modo, ZBrush. There are many others that can do it. With the examples here, 3D Coat and ZBrush would be the outliers. They're not a traditional 3D modeling software like the other four. So how they're going to use retopology tools on the surface might feel very similar to the other ones. The others being 3ds Max, Blender, Maya, and Modo. With those programs, you'll have access to their entire modeling toolkit as opposed to just a set of retopology tools. In the next video, we will be going over how to use retopology tools inside of Modo.